Good morning, Gladiators. Today is Thursday. It is February 11th, and today we're taking our Components of the Universe test. Before we do that, I do want to go over a few of these review questions from yesterday. So the first one that we're looking at here is the electromagnetic spectrum. You're asked to identify which form of radiation has a wavelength of 10 to the negative 8. Remember, when you're looking at the spectrum, you have wavelength and you have frequency, so please make sure you know which one the question is asking for. In this case, it's wavelength, so I'm looking up here. 10 to the negative 8 would be ultraviolet. Reading the HR diagram, remember, luminosity at the bottom is the lowest. These are the dim stars. At the top, these are the brightest stars. Temperature on the right is coolest. Remember, red is cool. Blue to the left is hotter. So if I'm looking at patterns here, I can tell that star C is hotter than star A, but it's slightly brighter because it's higher up. Star D is much cooler, but it's part of the supergiant group, so it's going to be much larger. So remember, you have the supergiants, giants, main sequence, and white dwarfs. Looking at the spectral patterns, remember you just need to match the pattern. So there's two yellow, and then I have a reddish-orange, a blue, and purple, or reddish-orange, a blue, and purple. So hydrogen and sodium would be found here. Put these in order from largest to smallest. So the largest is going to be the galaxy because that can contain billions to trillions of stars. Behind that would be a nebula because a nebula has to be bigger than a star because it actually contracts to make the star. And then a star is orbited by a planet, and a planet is orbited by a moon. So largest galaxy, then nebula, star, planet, moon. Remember, the Big Bang Theory was a theory used to explain the origin of the universe. All matter was composed to one dot, and it was released through a giant explosion. Make sure you understand the information about our sun. Our sun is the only star in our solar system, right? So a solar system is one star. It is the closest star, which is why it appears so bright and gives us so much energy. It is found in the Milky Way galaxy, but it is one of trillions of stars in the Milky Way galaxy. It is not the only star. Now, in the Milky Way galaxy, remember, we are located on one of the outer arms. We are not in the center. And then finally, it will not become a black hole because it's a small star. It will become a white dwarf, possibly a black dwarf. When we look at stars, remember the size of the star, the mass, determines its lifespan. The smaller stars tend to live longer because they don't burn through their energy as fast. So your largest stars are going to be the ones that die out first. So another electromagnetic spectrum, remember the connection between wavelength and frequency. So those with longer wavelengths, radio, microwave, infrared, have a shorter frequency. Shorter wavelength, like X-ray and gamma, have a longer frequency or a higher frequency. Right? Okay, so those are just a few things to review before you take your test. So you do have your test today. It is in CMS like always. Your test code is here. Make sure you read each question carefully and choose the best answer. When you complete that, if you are in pre-AP, you must do an FRQ. Complete the FRQ in complete sentences. I cannot stress that enough. I cannot grade it unless it's in complete sentences. So with the FRQ, here's your question. You have 4 parts. A, describe the characteristics of star A, including size, temperature, color, spectral class, and luminosity. Letter B, identify the next stage in the life cycle of star C. Letter C, identify the letter that most likely represents our sun. Please don't just put the letter, you must put it in a sentence. And then compare the characteristics of star D to star E. You must include size, temperature, spectral class, and luminosity. Answer in the table below. When you finish that, you can submit that, and you are done for the day, Gladiators. As always, I'm here to help you, so you can join us on Zoom, or you can message me and I'll get back with you. Have a great day, Gladiators.